This is Math 2. We're going to be practicing the stuff we learned in Unit 6 about triangles. You'll see these first 6 questions have to do with special right triangles, 45-degree angles being marked in questions 1, 2, and 3, and 60 or 30 being marked in 4, 5, and 6. Then 7 through 10, the last few questions on this worksheet, are just dealing with Pythagorean Theorem and hopefully recognizing the triples that they're based off of. So we're just going to work through these as we go through this, getting ready for the quiz that you guys have on Wednesday, giving us a chance to be prepared for those. So this will be the bigger focus of the quiz than the second part. There's probably going to be one question from the last set, and I would say 2 to 4 from this set. I haven't decided how many I'll get in, but at least 2. I'm hoping for 4. It depends on how long I think it will take. It still has to be done in 20 minutes. So the thing I noticed, since this is 45 degrees, is that V has to also be 10 because it must be isosceles. So that's the first thing to recognize, is that this, and so once I know that, the Pythagorean theorem can really help me out here, or I can remember. So I'm going to go ahead and do the Pythagorean theorem. 10 squared plus 10 squared equals my unknown, in this case u squared, which will be 100 plus 100, which is 200. And so 2 times 100, take the square root of that, equals u. And so u equals 10 radical 2. And so now what's kind of coming back to me is that the hypotenuse is the short side times the square root of 2. So with that in mind, when I look at question number 2, which gives me the hypotenuse, now I'm given the hypotenuse is 2 radical 2, I can use that to help me figure out the short sides without doing the Pythagorean theorem. But I do know that x is equal to y, so that's an important know. I know x is equal to y. So if I can't figure this out, I can still use the Pythagorean theorem, because I can say I have 2x squareds, or I can, it's a little weird. So this is x, right? So we can say x squared plus x squared, because they're both the same, equals 2 radical 2 squared, which is pretty ugly. I really want to be able to use the shortcut on this. So the shortcut says that the hypotenuse, the longer side, is equal to the leg, and the legs are the same, the leg times the square root of 2. And since this is the leg, so it's supposed to be x times the square root of 2 equals 2 radical 2, meaning that x is 2. And so is y. But let's prove it with the Pythagorean theorem. We're going to go ahead and go through that. Let me use a different color. So we've got 2x squareds equals 2 squared is 4. The square root of 2 squared is the square root of 4, which is 4 times 2. So that gives me 8 equals 2 square root 2x. X squared equals 4, and x equals 2. So I can just use the shortcut, knowing that it's supposed to be the leg times the square root of 2 to get me that, meaning that I'm just looking at 2. I like this one's easier, but you can use that. Now, 3 is the tricky one. I'm going to let you think about 3. We know that m and n are the same. I'd rather write n than m. It's a little shorter. And so I know that n squared plus n squared equals 6 squared. So I can do the Pythagorean theorem, or I can try to use the knowledge that I have. So my or, so I can do the Pythagorean theorem, which I actually recommend on this one. Or I can use the fact that n times the square root of 2 equals 6. And see, that's a harder problem to solve. Either one of these, solving for n, will give you the answer. So go ahead and try number 3. And so I did the green one first, and I divided by the square root of 2. This is correct, but we need to be in simplest radical form. So I times 6 over the square root of 2 by the square root of 2 over the square root of 2, giving me 6 times the square root of the 2 on the top. And on the bottom, the square root of 2 times the square root of 2 is the square root of 4, which is 2. And so then I just simplify that up. I don't like this way. I find it confusing, even though I can do it. I like this way. N squared plus n squared equals 6 squared. So 2n squared equals 36. N squared equals 18. N is equal to the square root of 18, which when I put it in simplest form, radicals in simplest form, then I get 9 times 2. Square root of 9 is 3. The square root of 2 is the square root of 2. And so m and n are both 3 radical 2. And you can use that wherever you want. Okay, so that's one of our two special patterns. Our other special pattern is the 30, 60, 90 triangles. We kind of have to shift modes. So here we know that it's isosceles, and we get to use that. And it's really very helpful that it's isosceles. Two of the numbers are going to be the same, and one is going to be different. Typically, and what's interesting back here is that the square root of 2 will either be on both of those or on the hypotenuse. I like it when it's on the hypotenuse best. It's easier. So 30, 60, 90 triangles, I kind of have to remind myself where they came from. So a 30, 60, 90 triangle came from an equilateral triangle that was cut in half. Okay. So the short leg used to be the same length as u, but it got cut in half, which means that u is equal to 2 times the short leg, in this case 14. Once I know that, I can use the Pythagorean theorem, or I can continue with the pattern. So we'd have 7 squared plus u squared equals 14 squared, and then I can just solve for u. Or I can remember the pattern, which says it's the short leg times the square root of 3. Now the pattern's harder to remember. Okay? So I can use the pattern. Now let's prove that the pattern does work and it is correct. We're going to go ahead and solve this. 7 squared is 49 plus u squared equals 196. U squared equals 196 minus 49. Is 147. And so u equals the square root of 147. I'm going to divide that by 3, which gives me 49. 49 times 3 is 147. Square root of 49 is 7. Square root of 3. And there's that. So again, the Pythagorean theorem can always bail you out if you don't remember the patterns, which is nice, because the patterns are hard to remember. All right, looking at this one, this time I know the hypotenuse because I have the side opposite the right angle. V is my short side. In this case, V will be 5. So with these, you do have to remember that relationship of the hypotenuse and short leg is half or double, depending on which way you're going. So you do need to remember that, but you can get away with not remembering what the middle leg is most of the time. And so I'm going to go ahead and I think if I use the pattern, u is 5 times the square root of something. If it's 3, all 3 different 3. Or I'm going to do the Pythagorean theorem. 10 squared is equal to 5 squared plus u squared. 100 is equal to 25 plus u squared. 75 is equal to u squared. Square root of 75 equals u. 75 divided by 3 is 25 times, so 25 times 3 is u, and so the square root of 25. 5 radical 3 equals u. Okay. Number 6. So this time they gave me the long leg. So when they give me the long leg, the problem is harder. And I didn't make this one terribly hard because I did not make it a whole number. If I'd made it a whole number, it's really mean. But so since it's 4 radical 3, I know that B is 4 because it's the short leg times the square root of 3, and A is 8. Okay? So it just takes a little bit of effort, a little bit of tweaking, nothing too much, nothing too troublesome, just a little bit of stuff. So that's 30, 60, 90 triangles. Now I'm going to go ahead and move on to the Pythagorean Theorem problems here at the bottom, which are really based off something, if you recall, called Pythagorean triples. The easiest of the Pythagorean triples is 3, 4, 5. Because 3 squared, 3 and 4 would be the legs, and 5 is the hypotenuse. Okay, 3 squared plus 4 squared, 9 plus 16, which is 25. And hey, 5 squared is 25. So if you can remember the triple, it saves a ton of time. Okay, so look at this triangle. This is 3 times 3. This is 3 times 5. I wonder what x is. If you know, go ahead and answer. If you're still not sure, let's do the Pythagorean theorem. So x squared plus 81 equals 225. X squared equals 144, and the square root of 144 is 12. So x is 12, which was, if you didn't notice, 3 times 4. So the Pythagorean triple, 3 times 3, 3 times 4, 3 times 5. Then this 3, 4, 5 pattern will work for 9 and 10. The other next smallest triple is the one that's represented in this triangle. So let's go ahead and do the Pythagorean theorem. X, let's use a different color. X squared plus 12 squared equals 13 squared. X squared plus 144 equals 169. Subtracting 144 from 169, I get 25, and x is 5. And so my other triple is 5, 12, 13. Now there are infinite triples. There's lots and lots and lots of them out there. These are what I personally call base triples. I don't really remember what they're called. Pure. They're probably called pure. Or, I don't know. So but this one is the most common. We use that the most. This is second. Beware of both of them. So this, let's see if we can find the pattern. So 12 is 3 times 4. 20 is 5 times 4. And now you notice I've got 3 and 5, both times the same number. What is x? If you know right now, awesome. If you don't, you can use the Pythagorean theorem. In this case, it would be 12 squared plus x squared equals 20 squared. Or you can use the pattern. Go ahead and solve for x. So I noticed, okay, so it's 3 times 4, 5 times 4, so this leg must be 4 times 4 or 16. That's the easy way. Then did the Pythagorean theorem to back myself up, and for those of you who did it the other way, 144 plus x squared equals 400. Subtracting 144 from 400, I get 256, so x in the square root of 256 is 16. Alright, so this is the last one. I definitely do not want to square these numbers. I can, I don't want to. 5 times 20, 3 times 20. I wonder what x is. You may either use the Pythagorean theorem or the pattern to find it. Go ahead and pause the video and find out x. Again, using the pattern, 3, 5, both times 20, so 4 times 20, so 80. Doing the Pythagorean theorem, 60 squared plus x squared equals 100 squared. 60 squared is 3600, x squared. 100 squared is 10,000. Or 100, whatever you want. Subtracting 36 from 10,000, I get 6,400. Square root of 6,400, I get 80. I really like triples. I also still like the Pythagorean Theorem. Again, it'll be my backup in case I don't remember. All right, I hope you have a good quiz and a good day. I will see you guys soon.